Now continue. The gas mixture is then passed through two consecutive rad-frac columns in series. Okay, so first let us take the rad-frac column over here, and this one we connect to this rad-frac column. The column has 14 stages. All this information is given, and then the distillate is fed to the second column while bottom product is recycled back as recycle stream as mentioned in the beginning of the stream. So the bottom product is the recycle stream, whereas distillate is fed to the second column. And we have a total condenser over here. Okay, so we shall have this as a recycle stream, which is coming back to the mixer. And this one is the total condenser. Okay, and we will rename the stream first. So this is the recycle stream. This one is the dist one out, and this is dist one. Okay, now let us open distillation column 1, and then we specify all those configurations. So first column has 14 stages, with 7th being the feed stage. So it is 14 stages. It has total condenser. So condenser is total. The reflux ratio has been given. It is 6. Reflux ratio 6. Distillate to feed ratio 0.387. So it is 6. And distillate to feed ratio, it is 0.387. Okay, and then in the stream we have to specify the feed stream, which is 7th. So we have 7th as the feed stage. Pressure, it is said the column running at constant pressure of 29 bar. So it is 29 bar, the entire column pressure drop is 0. Okay, so that's how we fix the distillation column 1. Now the second column is similar to the first one with the following changes. So what we will do, we will copy the first column and second column will be generated, and we will change those data, all remaining same. So we copy and then paste, edit the ID to distillate 2. Okay, so this one will go into the distillate 2. And here you can see the distillate is primarily methane, while bottom product is primarily ketone. And this ketone is fed to the CSTR. So, and here we have reflux ratio, distillate to feed ratio, entire column pressure. Nothing has been told about the condenser. So it is same as before, it is total condenser. So we shall take it as a total condenser, liquid distillate. This one is ketene. So we will write it as methane. And this one is ketene. And then we have to change certain things. First is reflux ratio. It is 4, right? Yeah, reflux ratio 4, distillate to feed ratio 0.5. So we'll write here 4. This one is 0.5. Then go to the stream. It is 7th stage as before. So we write 7 over here. And the pressure, I think we have to use 28 bar. Okay, so it is 28 bar. Right. Now one thing we have missed out over there, in the column 1, the condenser uses refrigerant 4 while reboiler heats up with high pressure steam. So we need 2 more utilities over here. So in the column 1, condenser uses refrigerant 4. So we use refrigerant 4, which is refrigerant 4. Okay. And reboiler heats up with high pressure steam, right? So again, we will use a new one. We write HP steam, which actually is high pressure steam. So that's how the utilities for condenser and reboiler is fixed. In the distillate 2, we have the same utility for condenser, that is refrigerant 4, but in the reboiler case, they said that the reboiler heats up with low pressure steam for the second column, right? So in this case, again, we will use another utility, that is low pressure steam, copy from LP steam. Okay. That's how the distillation column 2 has been specified. Now the ketene will go into a reactor. That's what it is said. Ketene is fed to a CSTR where acetic acid is also fed. So we will bring in another reactor, which is a CSTR, and this will be fed to CSTR, and CSTR will have another input, that is acetic acid, and this will be the product, that is acetic anhydride. So this is, we call it our CSTR, reactor CSTR. Okay, and this one is acetic acid. This one is product, that means the acetic anhydride. Okay, now we have to specify the particulars of acetic acid. So let us open this one, input. It says 17.126 kilomole per hour, 25 degrees centigrade and 15 bar. So acetic acid 17.126, yes, 25, 15. So it is 25, here it is 15, right. And we have to go to the RCSTR. The CSTR operates at 75 degrees centigrade, 15 bar, and its residence time is 1.5 hours. So it is 15 bar, 75 degrees centigrade, and the phases are liquid only because now it is liquefied because it is coming from the bottom. And we have to specify the residence time, which is 1.5 hours. Okay. Now go to the kinetics. We have to use a new equation, and the new equation, we have to identify it as an equilibrium reaction between ketene and acetic acid produces acetic anhydride. So it's an equilibrium reaction. Ketene plus acetic acid produces acetic anhydride. Okay. We do not need to specify any particulars in this equilibrium condition because it will compute the K equilibrium from Gibbs free energy. Okay. So that's how the specifications for the entire sheet has been complete. Now the required input is complete. Now we have to specify the utility for CSTR, right? So what is that? CSTR is cooled with standard cooling water. So we have to again open CSTR and utility. We don't have cooling water over here, so we have to specify another utility, that is cool watt. Okay, which is actually cooling water. So right, so these are cooling water. Now mind that we have called several utilities over here: air, cooling water, electricity. Now for each and every one of them there are certain default values. For instance, the cooling water inlet temperature is 20 degrees centigrade, outlet temperature is 25 degrees centigrade. Okay, so this is the default values of cooling water inlet temperature and outlet temperature. But in case we want to change the values of cooling water temperature, there is an option over here. We can change them. We can change it from 20 to 21 or 22, or we can make it 25. This one we can make 30. Okay. Basically, cooling water is something which is naturally found. We draw it from the water source, which is at ambient temperature. So for cold countries, it may be very cool, around 10-15 degrees centigrade, but in somewhere in Middle East, it may be at higher temperature. So it depends upon the place where the plant is operating. Similarly, electricity. Now, in the electricity condition, we do not have any specific purchase price at this moment, so it has taken some default value. Here also it depends upon place to place. Probably it has taken the default value somewhere in US, but in India it will be much cheaper. The electricity price changes. It will be different for different states in India. So let us not talk about the utility now. We have the required input complete, so we can run the process first. Yeah. So the results are available. Okay. So results are available. We can just check the temperature, pressure, and the molar flow rate. You can see the acetone. We can change the we take one digit after the decimal point. Okay. So it is 68.5. So fired heater is heating the feed from 68.5 to 761.9. So PFR is operating at vapor phase. And then it is coming out at 627.8 degrees centigrade. Perhaps the PFR is endothermic. And then this is cooled to 140 degrees centigrade, and then it is cooled to 90 degrees centigrade, and then it is again pumped over here, and you can see the temperature. It is 150 degrees centigrade. If you remember, in the compressor, the last stage, it operates at outlet temperature of 150 degrees centigrade. So it is at 150 degrees centigrade. It is going into the distillation column. We are using a refrigerant to cool the condenser. So as a result, distillate is coming out at minus 59.3 degrees centigrade, while the bottom product is coming at 203 degrees centigrade. And this is the recycle stream, which is mixing with the acetone at 25 degrees centigrade, and the resultant temperature is 68.5 again. And this one is going into the second distillation column. The condenser is operating with refrigerant 4. And now methane is coming out at minus 97.1 degrees centigrade. So it is liquid methane is coming. While the bottom product, ketene, is coming at 58.7 degrees centigrade, and this is going inside the CSTR. It is reacting with acetic acid, and the product, that is acetic anhydride, is being produced at 75 degrees centigrade. So the pressures are also given as it has been set, like 1.5, 1.5 up to this point, and then compressor is lifting it up to 29 bar, and then here also 29 bar is maintained, and then this is coming at 28 bar, and here it is 15 bar. So the CSTR is operating at 15 bar, and the molar flow rates are also given. So actually, if you put it over here, you can check how the things work. Okay, so this is the complete run that we have done. But today we will learn the economic analysis of this particular problem. Now for that, you have to provide certain extra information in the setup. First, you have to specify the costing option. Okay. So in the costing option, you have to provide the information on operating life of the plant and length of plant startup. If you go back, the operating life of the plant is 20 years and length of the plant startup is 20 weeks. So this is 20 and this is also 20, but it is week. So what it says that the plant will be operational within 20-week time and it will operate for 20 years. So basically, operating life of the plant means that this plant will be operating for 20 years. Before, probably we have to do some changes in the equipment or some other renovations that we have to do. For the time being, with this design, we'll assume that the plant will be operating for 20 years. And within 20 weeks, the plant will be starting up. Start of basic engineering. This is 1st July 2025. So it is 1st July 2025. Okay. Now there are templates available. Okay. These are economic evaluation template. So you can call those templates. But if you do not want to use a template, if you want to develop something of your own, you may not need the template. You write scenario 1 and description, you can write something. Economic analysis of the plant. Okay. Or you can provide some better description of what the scenario 1 is, because there might be 3 or 4 or 5 or 10 scenarios, different scenarios that you want to produce and show to the person who will ultimately take the decision. Okay. Because in process plants, usually multiple designs are produced before they discuss it thoroughly, and after the thorough discussion, they arrive at a decision that design number 3 will be used and sent for development and commissioning. Okay. So multiple designs may be required for that analysis. So you can say scenario 1, scenario 2, scenario 3 and rerun for various scenarios. So let us say scenario 1, okay, and the currency. By default, it is the US dollar. But you can use some other currency also. For instance, if you want to perform this economic analysis in India, then definitely you would like to use Indian currency, right? So you can always write INR. And what is the conversion factor between the INR and dollar? So you can write 85. On today's date, it may be 85 or 86 or 87, I do not know, but you can change the conversion factor at any time, okay, and rerun the process. So for the time being, let us keep the conversion factor 85. Then we have to provide the stream price. So these are the streams. Acetic anhydride. So you write acetic anhydride. That is the product. Okay. It is $1,000 per ton, right? Acetic acid is 600. So acetic acid is 600. Acetone 1200. and then methane 6150. Okay, so these are the stream prices. As we have discussed, acetic acid and acetone, we have to spend money on purchasing them, while the product and methane we can sell and you can run. But then there are options for performing the economics analysis. One is by choosing this one. If you turn it on, then all of them will be calculated of its own. Map will be active, size will be active, view equipment will be active, evaluate, everything will be active. Okay. So this is the route one. But the more elaborate process is by sending to the APEA. APEA means Aspen Process Economic Analyzer. So this Aspen Process Economic Analyzer is another platform which is separate from Aspen Plus. It takes up the information from Aspen Plus and it does all the calculation. Okay. So first we will see it through the second way, that means by sending it to Aspen Plus Economic Analyzer, and then we'll come back to the first one, that is by turning it on, and we can just show how the things are comparable with that. Why I am trying to show this one? Because it is quite elaborate and you can perform many more things which is possible over here and it might not be possible over here.